Hi, welcome to Chingster's video on operation in scientific notation. In this video, we're going to learn about adding and subtracting numbers in scientific notation. So, if you can recall what it means to be in scientific notation, a number written in scientific notation is written in the form of a times 10 to the power of n, where a is greater than or equals to 1 and less than 10, and your n here is an integer. Okay, and let's look at the first example when we have 4.25 times 10 to the third adding to 6.25 times 10 to the third. So let's see how it works out when we rewrite it in standard form. So we know that 4.25 times 10 to the third, if you have 3 decimal places, this ends up as 4,250 plus, and this 6.25 in 3 decimal places, 6,250. And if you were to add these two numbers, okay, so if you're gonna put 6250 here, if you add these two numbers, you're gonna end up with 10,500. And 10,500, if you write it in scientific notation, we're gonna have the first non-leading zero digit, which is 1. So you have 1.05 and times 10 to the, let's see, this number 10,500 is decreased by 4 decimal places, so 1, 2, 3, 4, and so the exponent of 10 should increase by 4. Now we're going to look at how we can use the rules of exponents to help us simplify this sum. So we can see that both numbers are returned to the same power of 10. So we can use factoring to help us simplify this sum. I can write it as 4.25 plus 6.25 times 10 to the third. So from here, I can add up these two numbers. So if you add up these two numbers, you're going to end up with 10.5 times 10 to the third. And again, the coefficient is not in scientific notation form. We need to rewrite this. So I have to make 10.5 into a smaller number, which starts with 1, will be 1.05. And when you decrease the decimal place by 1, you will have to increase the exponent by 1. So this is what I got, and I had to rewrite 10 to the third below. And using the product of powers property, I can add the two powers, and I'll end up with 10 to the power of 4. In this next example, we will see how we can subtract two numbers in scientific notation. So 6.25 times 10 to the power of 3 minus 4.25 times 10 to the power of 3. So from here, you can see that I will first rewrite it in standard form. So 6.25 to the third power is actually 6,250, and subtracting 4.25 to the third power is 4,250. And from here, you can see that I end up with 2,000. And 2,000 is returned as 2 times 10 to the third in scientific notation. So we will now see how we can use the rules of exponents to help us simplify this subtraction problem. So we can first factor out 10 to the third power that is common to both numbers. So, and I can rewrite this as 6.25 minus 4.25 times 10 to the third power. Okay, and from here, 6.25 minus 4.25, and you end up with the 2 times 10 to the third. And very nicely, the coefficient here is greater than or equals to 1 and less than 10. So this is already in scientific notation. We got the answer. And you can see that this answer is the same answer as we got on the left-hand side. Now let's look at example 3. I'm going to look at 4.25 times 10 to the third plus 6.25 times 10 to the fourth. You can see, in this case, you can see that the exponent of both tens are different. One is to the third, one is to the fourth. So let's look at it in terms of using standard form and see what we will get. So from here, 4.23 times 10 to the third is moving by multiplied by 1,000, so you get 4,250. And 6.25 times 10 to the fourth is multiplied by 10,000, so you end up with 62,500. So if you add that up, it's gonna be 4250. So you're gonna end up with 6,750. So if you want to write that in scientific notation, so you will have to put 6.675 and multiplying that by 10. We'll see what exponent we're going to multiply that to. So 6,750. When you reduce this number by 4 decimal places, you will have to increase the exponent of 10 by 4. So that's how you get in scientific notation. So let's look at this example when we're using the rules of exponents. So all right, so in order for us to apply the factoring rule for the 10, we need to make sure that they both have the same power. So we can rewrite the numbers to the 10 to the, say, third. So I'm going to write it as 4.25 times 10 to the 3 and plus, in order for us to decrease this power of 10 from 4 to 3, I will increase this number by 1 decimal place. So I end up with 62.5 times 10 to the third. So once I have these two tens to the same exponents, I can apply the law of factoring to help us. So I end up with 4.25 plus 62.5 times 10 to the third. So now I will add these two numbers and I will end up with 66.75 times 10 to the third power. So in this case, my coefficient is not in scientific notation. I need to rewrite it such that I end up with 6.675 times 10 to the power of 1. Because when I reduce 66.75 by 1 decimal place dividing by 10, I need to make sure my 10 power is increases by 1. And I'll bring this down so I get 10 to the power of 3. And now applying the product of powers property, I'll end up with 6.675 times 10 to the power of 1 plus 3. So I end up with 6.675 times 10 to the power of 4. And you can see that I get the same answer in both cases. Okay. Some of you may be asking, can we rewrite the two power of 10s to the power of 4 instead. Let's see what happens. So we have 4.25 times 10 to the power of 3 plus 6.25 times 10 to the power of 4. We want to rewrite both as 10 to the 4th. So for this number, when you increase the power by 1, you will have to reduce the coefficient by 1 decimal place, so divided by 10. So you end up with 0.425 times 10 to the power of 4 plus 6.25 times 10 to the 4th. And when you add the two numbers up, after you factor 10 to the 4th, so 0.425 plus 6.25 times 10 to the 4th, you end up with 6.675 times 10 to the 4th. And you could see that you get the same answer, and for this case it might be easier because you don't have to do a further step of converting the coefficient in scientific notation. So both ways work. So now we look at example 4. So if you have 1 times 10 to the negative 3 minus 2.5 times 10 to the negative 4. Now these two exponents of 10, they are different values. So again, so it's going to be different from what we did for example 2. But let's look at these two numbers using standard form and see what you should be getting. So 1 times 10 to the negative 3 power, you should become divided by 1000, so you end up with 0.001 minus 2.5 divided by 10,000 will be 1, 2, 3, 4, so 0.00025. Now do the subtraction using the algorithm. So let's see what happens here. So you subtract these two numbers, so you'll end up with 0.0075. So this number in scientific notation is gonna be 7.5, and you will have to, since you're increasing this number by 10,000, 1, 2, 3, 4, and the exponent of 10 will have to decrease by 4. We will now look at how we can use the rules of exponents to help us in simplifying this subtraction. So again, you have to make sure that the two tens have to have the same exponent. So I'm going to use negative 3. So this will become 1 times 10 to the negative 3 and subtract. To make the second exponents from negative 4 to negative 3, I'm increasing it by 1. So I will have to divide my 2.5 by 10, so to get 0.25. So now the two powers of 10 are the same, so we can use factoring to help us simplify the subtraction. So 1 minus 0.25 times 10 to the negative 3. So I end up with 0.75 times 10 to the power of negative 3. And again, the coefficient is not in scientific notation form. I have to make it 7.5 times 10 to the power of 0.75 is increased by 1 decimal place, so I have to reduce the exponent of 10 by 1, and I have to bring down 10 to the power of negative 3. So, and using the product of powers property, I will have 7.5 times 10 to the power of negative 1 minus 3, so 7.5 times 10 to the power of negative 4. This answer is the same as the answer that we got when we did the work in standard form. Can we also rewrite both numbers as 10 to the exponent of negative 4? So the first number, to write it as 10 to the exponent of negative 4, I'm decreasing the exponent by 1, so I can increase the coefficient by 10. So it's 10 times 10 to the negative 4 minus 2.5 times 10 to the negative 4. And I can now factor the two numbers 10 to the negative 4 because they have the same exponents, and I'm left with 10 minus 2.5 times 10 to the negative 4. Now in this case, 10 minus 2.5, I end up with 7.5 times 10 to the negative 4. You can see I get the answer, the same answer, and in this case it's actually quicker, so something for you to consider. Now we're going to look at the rules for adding and subtracting numbers in scientific notation. Alright, so in scientific notation. So the first case is when they have the same power of 10. So a times 10 to the power of m plus b times 10 to the power of m. We know that in this case, I can factor out 10 to the power of m and then just add a and b together. Okay, and for subtraction, it will be the same. If you decide to have a times 10 to the power of m, subtracting b times 10 to the power of m, same thing, you'll just subtract the two coefficients and multiply it by the same power of 10. To get your final answer, you have to make sure that the sum and the difference have to be in scientific notation. So the coefficient has to be greater than or equals to 1 and less than 10. The next case would be when they have different powers of 10. You have to make sure that you have to rewrite them as the same power. So I'm going to look at this example. The rule a times 10 to the power n plus b times 10 to the power n. So you have to rewrite this two exponents, express both numbers as the same power of 10, then factor and evaluate the sum. Finally, rewrite in scientific notation. So it will be the same rule if you're going to use subtraction. So that's all for my video and examples, and be sure to do practice, and thanks for watching. Bye.